Okay, so as we see, some of these are include introduction, formation, classification, textures, structures, important sedimentary rocks, and engineering components. So the problem that we faced last time when we were referring to the some of the textbooks is like a little harder for us to understand from the textbook. So now we have some presentation coming in. So the basic idea of this presentation and to showing is that you see some of the features in terms of photographs, because in the human mind reads the photograph better than the text. So we'll go one by one and see. So sedimentary rocks, why we are focusing more on sedimentary rocks, because about 75% or 70% of land surface, the rocks exposed are actually sedimentary rocks. So that's why sedimentary rocks, they are very important. And the resources that we are finding ranging from uranium, from hydrocarbons, from coal and other minerals like sedimentary ore deposits. So they have a very vital importance, and understanding them will give you an insight into how these rocks look like in the field. So we have different sedimentary layers here, and lady maybe standing and trying to perceive these level of how these rocks were formed. So let's go back a little bit into the introduction part. So we go back a little bit and then try to understand. As you know, sedimentary rocks are formed from the breakdown of already existing rock, and the total volume of the crust, if you consider igneous metamorphic rock like the 65-kilometer depth, then it's about 8% of that is sedimentary rocks. So sedimentary rocks, they are very important, and they are important for us because our houses are most of the time located on sedimentary rocks. If you are like in the mountainous areas, so most of the mountain people, they build houses on the rocky. So understanding this will help us in the construction of roads, houses, tunnels, canals. As you know, you need aggregate material for the construction of roads, and that aggregate material sometime is limestone. So understanding how the limestone look like in the field will ultimately benefit you. Okay, so we have few students coming in the session. So most of the sedimentary rocks you see are formed at the earth's surface, and they are accumulated and lithified fragments of pre-existing rocks. The formation of sedimentary rocks, as you know, these are like the broke down pieces of already existing rocks that include the rocks that we have, the igneous metamorphic or already existing sedimentary rocks. So normally these rocks, in terms of temperature, if you say, okay, so we have this problem of okay, so we have some of these rocks that come from already existing sedimentary, igneous, and metamorphic rock, and they normally form at normal temperatures. So this thing will keep on coming. So let's go back again. Okay, so let's go and see some of these diagrams. And if you see, this is a sediment, and as sediment is deposited, this is the sea floor. So sea floor, and then we have increasing pressure, as well as the temperature will increase as we go to the depth. So successive layers, like you remember the law of super succession, or law of superposition, in which we say that this layer is older than this layer. So this layer was formed before all of these layers, so this is the older layer. So as the sediments are compacted, so they go to deeper parts of the earth, or the okay, okay. So we have then coming in of cementation. So what does cementation happen? So in cementation, we have the particles cemented and glued together. So these were separate particles. They were compacted together. The space between them is sort of reduced, and as a result, they come closer to each other. And as a result of that, later on, these particles, when they get cement, कोई भी ऐसा solution that is present in that particular environment that can work as a solution, so that solution, you just consider them as bricks. So you have bricks, and then you join those bricks very close together, and later on those bricks you introduce a cement, and those particles will be cemented together. So this is how a normal sedimentary rock forms. You have deposition in the sea, and then successive layers go to the deeper part, and then those deeper parts, we have the compaction coming in, and that compaction later on will be uh, manifested by cementation, and then cementation after that it will be formed in the form of a rock. Okay, so let's see the model that we have. So here you can see an igneous rock that has been weathered. So in that weathering, we have different type of minerals coming in. We have the quartz coming in, the clays, the calcite coming in the form of solutions. So what does happen? Quartz sand, if you see, this is a river or this is a beach, a river coming in form of a delta, and this is a beach area, then this is the shelf area, and this is the shelf. So consider, like for example, you are sitting here or standing here, this is Karachi, and this is the Arabian Sea. So you see that as you move away from the seashore, seashore, have you ever been to Karachi? कभी आप गए हैं seashore पे? आप में से कोई बंदा
Yes,
देख?
sir.
Okay, so once you see the sea, you will see waves coming in, and waves attacking the beach. And then if you go deeper in the from the shore towards the sea, तो आप देखेंगे कि वहाँ पर initially you will see sand deposition, and after that you will have the deposition of finer material, that will be the clay, or that will be okay. So that will be the clay, and that will be the clay, and then later on the formation of calcite, and as you see, the calcite is deposited here. And as you move away from the beach, you have more quieter and quieter environment, like the energy level drops from here until we reach the quieter part of the sea. So it means the nearest part will, you will have the deposition of sandstones, and then here chances that you will form shales, and here you will probably form the limestone. So if you see sandstone, shale, and limestone, their composition, so you will have quartz, feldspar coming in near the beach, then more clay minerals coming in here, iron oxides in the shales, and then you have the solution of carbonate saturated sediments, and then they will form in the precipitate in the form of a limestone. So you have siliciclastic rocks. These two are siliciclastic rocks, as we have already discussed, and this is a type of a chemical, or some people also call it as biochemical rock. So what does this is made up of? They can be made up of boulder, cobble, pebble, granule, sand, silt, clay. So these are the siliciclastic rocks. So we have already studied the Wentworth grain size scale, in which you have seen that boulder is larger than 256 millimeters, and similarly clay is smaller than 1 over 256 millimeters. Similarly, we have the chemical and biochemical rocks. So we have tried to see some of these rocks, but it will be more clear when we will see the coming up slides. So it is just a simple model. The idea one liner about this is like It shows that different regions in the sedimentary environment will have different sediments coming in depending on the source rock. What is the source rock? Like an igneous rock, if and the sediments will be this type, and then if it is a metamorphic rock, then the chances are there that it will be a different type. So it all depends on your source and what type of energy you have and what type of sedimentary setting you have. Okay. So as we have already done, the sedimentary rocks can be classified into mechanical rocks, mechanically formed or plastic rocks, organically formed, and chemically formed. Okay. So the clastic sedimentary rocks, as you see, they are normally called breccia, conglomerate, sandstone, and shale. So they are actually formed by weathering from pre-existing rocks. So we have okay. So each time we enter the students, we have to off the sharing button. Okay, so the following steps are involved in formation, that involves the disintegration and decay. So current rock mass are gradually disintegrated and loosened. So we will see if we have a diagram for that. So it will be easy for us to understand. Then it involves the gradual deposition. Of course, it involves transportation of the sediments, and it involves the, as we have already been studying these things in the geomorphic processes in geomorphology. So we will have wind, running water, glacial coming in, and then moving these sediments from one place to another. Then it involves the gradual deposition, and it involves that the according to their size, shape, and density, they are adjusted in the setting. Then, as we have just seen the example from the sedimentary rock, we have diagenesis. That is a process that converts a sediment into a sedimentary rock by means of compaction and consolidation and cementation. So here is an example how sedimentary clastic rocks are formed. So we have weathering and erosion of sediments, and then it involves the transportation, and then we have the deposition of these sediments, and as a result of that, later on we will have the burial, compaction, and lithification of these sediments. So you will see a series. This is a mountain, and from this mountain we have the if you see from this mountain we have the movement of some of the sediments are coming in from this mountain and then transported and then start depositing here, and then after deposition the deposition continues until here. So it indicates that the the sedimentary rocks that are formed involves weathering, erosion, transportation, weathering, erosion, transportation, deposition, and burial, compaction, and lithification. So all of these processes, as we have said, that they are more like of diagenesis. This part is more like diagenesis. This is the deposition, transportation, and this one is the weathering and erosion. And like most of these rocks, when they are exposed to the earth surface, so they are subjected to uh, different geomorphic agents that involves wind, water, glaciers, and in this case it's mostly water, and then it moves the sediments down the slope until they get compacted and lithified. So this is just a simple idea how this works. So here we have a simplistic diagram of how diagenesis happens. So this is the water. If you consider this one as, just consider this thing, and we just try to enlarge that here. Here we have water coming in. So this water always present, and these are the sediment, recently deposited sediments. So what will happen there? We have different type of processes, and we have some organisms coming in, and then they start transporting and the transformation of these sediments, and then they just destroy the sedimentary bedding, and then they continue working. And sometimes they also have what we call the trace fossils in the form, and they are the first one to start the diagenetic processes. And similarly, we have some EH, and other reactions coming in. And similarly, we have some of these suspended particles that continue to be settled, and as they are settled, we have coming in of different another layer here, and then this layer will be compacted just like one of this layer. And as diagenesis progress, so we have successive layers coming in. So just consider this one as A, B, and then we will have another layer coming in, and then we have another layer coming in, and then another layer, and then another layer. So this process will continue, and normally we call this process as sedimentary diagenesis. So then comes the chemical sedimentary rocks. So we just try to just introduce them, and then before we close this session. So chemical sedimentary rock, as you know, they involve rock salt, gypsum, anhydrite, and some limestones. Actually, these type of rocks, they form from the precipitation of already dissolved materials or minerals in the solution. So we have rock salt, gypsum, anhydrite, and some of the limestones that are inorganic. They form under this setting. Then comes the organo-sedimentary rocks. They involve coals and some limestones that are formed by most of the animal debris, especially foraminifera or mollusks. So we will try to discuss. Let us go to the. So this is another example before we close this session. Okay. Okay, so before we close this session, we have another example. We have a sedimentary rock. We have this one is the seabed, and you see this is the place where we have newly formed sediments, and as a result of once we have this layer coming in, this layer will the grains will come closer and closer. They will have compaction. Later on, the cementation happens, and as cementation happens, this bed will be converted into a sedimentary rock. So this is how this process continues for thousands and millions of years, and as a result, we have the formation of sedimentary rock. So this is the basic ideas we have about the formation of sedimentary rocks, and this is a little bit of theory behind the rocks you see in the field. So that's all from my side for today, and if you have any questions related to the topic, you can ask.
सर डायनासिस रिपीट कर दें.
Diagenesis.
Yes sir.
Diagenesis, Kaiser, is the process of converting sediment into a sedimentary rock. So we have some sediments as we have seen. Let me show you the. Okay, let's go back to some of these slides. So here we have this beautiful example. So we have the sediments are coming in from weathering and erosion of this newly exposed rock, and then they are transported, and then the deposition starts. And once the layer, जो पहली लेयर आपकी बनी थी उसके ऊपर और मजीद लेयर्स बनती गई हैं, तो जो नीचे वाली लेयर है वहां पर बरियल कंपैक्शन एंड यू हैव द प्रोसेस ऑफ लिथिफिकेशन कमिंग इन. सो एज अ रिजल्ट ऑफ दैट प्रोसेस, यहाँ पे जो ये लेयर होगी इसके अंदर क्या होगा, कंपैक्शन होगी, grains will become closer and closer together. Just consider this one as well. So you have the grains coming in, and then those grains will be compacted. So here is the start of diagenesis. यहाँ से diagenesis शुरू हो जाएगा. जैसे ही compaction शुरू होगी, diagenesis will start, and as a result of that, the compaction and cementation will come up. So compaction, cementation are two main type of processes that we have during diagenesis.